All right, so example 7, we're talking about Stacy and her playing tennis. I'm going to do it over here because my other camera's not working, so it's hard for me to record over there. So initially, the tennis ball is heading towards Stacy at 5 meters per second, right? Stacy then hits the ball, sends it back towards her garage door at 8 meters per second. And then the tennis ball comes back at Stacy at some unknown velocity. And we're trying to figure out that unknown velocity, given some other information about the situation. So, the first thing we know, the tennis ball comes towards Stacy, she swats with her racket, it's now going away, right? So, the ball's coming towards Stacy, her racket's over here. In my attempt to draw a tennis racket. Okay. So, the tennis ball hits the tennis racket. I'll color in the tennis ball so we can see it. Which way does the racket apply a force to the ball? Oh, we didn't talk about positive direction. Thank you. Thank you, Richard. So we called that way positive. So which way is the positive direction? To the right. So the racket applies a force to the ball this way, right? Which way is the impulse exerted on the tennis ball? Which way is the impulse? To the right. Good. Because impulse and force are in the same direction because J equals F delta T, right? That's why we call it Jimpulse. Right? Does that make sense? Does that make sense? Okay. What else? If I want to figure out my impulse, do I use that equation? No. We know nothing about time. We know nothing about force. What do we know?
The mass.
Change in momentum or change in velocity, right? Because mass doesn't change, does it? Mass doesn't change, right? All right. So if I figure out mass times the change in velocity, we can figure out our impulse. Okay. So the mass of the tennis ball was 0.057 kilograms, right? V initial up here is -5. V final is +8. Negative sign matters, doesn't it? Because momentum has a direction. Perfect. Right? So, change momentum, 0.057 times V final minus V initial. So 0.057 times 13. What does that equal?
0.74.
What is it?
0.74.
0.74 kilogram meters per second. Does that make sense? That part does. So how does that part make sense if the next part doesn't? Yeah, there is. They said the garage door exerts half of the impulse as the tennis racket does. Exerts half the impulse. We can go into the whole reason why if you want to. The tennis racket flexes, right, and bends, and kind of launches the ball off, right? Does the garage door flex and bend and launch the ball off? Yeah. No. So you lose some energy. But we'll go back. So the impulse is half as much. So 0.74, if I'm talking about the garage door tennis ball interaction, so right here, impulse is not 0.74. It's 0.74 times 1/2, which is
0.37.
0.37. You got it in your head? Okay. So the impulse now is 0.37, right? If I want to find final velocity, do I use the first one or second one? Second one, right? So J equals change in momentum, which is m times the change in velocity. Right? The 8, is that my final or my initial?
Initial.
That's our initial now, right? That's positive. And our final, we don't know. So Kevin, what do you mean we don't have enough information?
I just saw that part.
Okay, you forgot about the half part?
Yeah.
Okay. So we got 0.37 equals 0.057 times V final minus 8. This changes final minus initial, right? So what should we do now? What should we do? What? We solve for VF, right? So we divide. .37 divided by .057 or .05, yeah, .057. 6.5.
Yes.
Okay. So what do we do now? Oh, I forgot something. What did I forget? This impulse is negative because the garage door over here, when the ball hits the garage door, which way does it apply force? To the left, right? Which is negative. So our impulse is also negative. Thank you for reminding me of that. Okay. So this 6.5, is it positive or negative? Negative. So what do I do now? Not subtract. Add 8. Guys, I know you know how to do algebra. Just tell me. Right? Negative 6.5 plus 8 is? 2.5?
It's 1.5. It's actually
1.5?
Yes.
Interesting. Thank you. All right, any questions? Any questions? Now, when I was setting this problem up, I think I made a slight error because this means the ball goes through the garage door.
Because it's greater than
Stacy is a beast. All right? It means the ball goes through the garage door. Okay. No, it's because our final velocity is positive, so it means the ball's still going in that direction. Okay. So that's an error that I made when I was calculating. Maybe I should have done 3/4. So sorry about that. I'm guessing I made the same sign error and then just kind of took care of it later. All right. So the problem makes sense mathematically, and unless Stacy is just, world-class tennis player, the final velocity doesn't really make sense. But the idea is there. Yes, Kim.
What if we did the